So we finished chapter 13 and chapter 14, which is the discrete random variable, when we only take countable number of outcomes. So chapter 14 is talk about binomial distribution. So we have all that kind of special formula here. Okay, so what we'll learn for continuous random variable, again, you know the table is a general method and the binomial is a special one. So in chapter 15 and 16 is the same thing. We learn a general continuous random variable, like a way to express general one, and then we have a special one, like which is called normal distribution. So that's 15 and 16 is talking about. So for this exercise, what we talk about is when a variable can assume any value within a particular interval, then this variable is continuous. Okay, I explained like measurement value, most of them are continuous values. The height of a person, like a 50-year-old male, the water in a water bottle for 600 ml water bottle, so 0 to 600. So we have late. We have something called continuous random variable. So a continuous random variable can be described as a probability density function. So what I'm talking about here is before we have a probability distribution table, like a probability distribution function or called a mass function. So for this value, we have this probability. For this value, we have this probability. We're listing them out, or we use a function, and then we know what is the given x. But for this one, we use a density function. It can only be done by a function. It's not going to be done by a table. So only done by a density function. So what's a density function? That display the following properties. So it must satisfy the following property. So the density function first, let's talk about the condition first. So the condition first is this whole function needs to be above the x-axis or equals to 0. Okay, so it's greater or equals to 0. So the whole function must be above or on the x-axis. It's not going to be below the x-axis. The second thing is the area under this function must be 1. Okay, the area under this one. There's two restrictions. Like remember for the table method, for the table, what we have is for each individual those values, it needs to be in between 0 to 1, like probability needs to be in between 0 to 1, and when I sum all of that, that must give you 1. Okay, when I sum all of that, that needs to give you 1. So very similar thing here. So everything needs to be above the x-axis. There's no restriction of 1 on the side, but needs to be positive. The second is the area under the whole function needs to be 1. So why we have that? Okay, why we have that? Because we can go up to see what is, how do we use Oh, very nice dress. So how do we use density function? Why is important for density function? How do we calculate probability by using a density function? So I will just draw a density function for you. Well, that might be a density function. So first of all, everything is, there's another thing I need to talk about, but let's finish this first. So this is a density function fx, okay? Density function is fx. So we have, for example, this point is -1, this point is 6. Okay, so domain is -1 to 6. So only measure things from -1 to 6. Okay, so if I also talk about the probability of not -1, let's say from 0 to 2. From 0 to 2. If I want to talk about the probability by using this density function, I will find the area from 0 to 2. This area will give me the probability. So if I can anti-diff the curve from 0 to 2, I will have the probability. So the area under the density function will represent the probability. Okay, will represent the probability. So we don't take values, we don't sub things into the function. We take the area under the curve that will represent the probability. So the probability from 0 to 2 is the pink area, so whatever the area is. So again, what's my domain? My domain is -1 to 6. Okay, -1 to 6. So the x only available from -1 to 6. Or say the water in the water bottle, the x is only available from 0 to 600 mils. So it's only available for that part. For the rest of below 0, I can't get water below 0. I can't get water overfilled like to 700 mils. So it's not going to take those values. So the possible domain is only -1 to 6 according to my graph here. So area under the curve, everything under the curve now should give you 1 because it shows you all the possibilities, all the possible values you can have. Therefore, the total area under the curve must be 1. So I should have the whole area. That's also what we're talking about here. So all the area under the fx function should give you 1 because that represents everything. I should include everything and the total probability is 1. And also everything must be above the x-axis because I don't have negative area. Like I don't want negative area. All the probability needs to be in between 0 to 1. So everything needs to be above the x-axis, not below the x-axis. I don't have negative probability. If the area is under the curve, under the x-axis, which means I have negative probability. That's not true. So therefore, 2 requirements. First, I need to have the function above or equals to 0. Second, I need to have the total area under the density function to be 1. Okay, so when they ask you to test that, to prove that, you need to prove 2 things. First, sketch the graph to show it's above or equals to 0. Second, anti-diff the graph for the given domain and show the area is 1. That's the 2 things to show this is a density function. Okay. The second thing is really, really important. Can you see when we take equals to B equals to A, not equals to B, not equals to A, not equals to A but equals to B, equals to A but not equals to B. It doesn't matter we take the endpoint or we don't take the endpoint. It's the same thing. Okay, it's the same thing because I'm talking about the area in between A and B. I'm not taking the value of A or taking the value of B. Like it doesn't really matter. I have that line or we don't have that line. There's no area on that point. So there's no area on that point. So therefore, whether we take the endpoint or we don't take the endpoint, we have the same probability. That is different from the discrete probability. For discrete probability, binomial, for example, I said x equals to 3, x greater than 3 and x greater or equals to 3. That will be 2 different probability, right? One is 3 to n, one is 4 to n. So it is different. But for continuous, doesn't matter about the endpoint. We include the endpoint, we don't include the endpoint, it will be the same. Also, it shows you why at A, at B, there will be no probability. Because if I'm trying to calculate probability x equals to something, say I want to find probability x equals to 3. X equals to 3 is here. Okay, that is x equals to 3. That line is x equals to 3. But there's no area. So I'm trying to integral from 3 to 3 of that function. But I have no area, so it's 0 area. So for a line, there's no area. So therefore, on a single point, there's no probability. So I will say probability x equals to x is always 0. There's no probability on a single point. Also, another way to think about this is I can't have probability on a single point because I will have infinitely many points, right? Like it's a continuous random variable. I will have infinitely many points. If every point got some probability and I'm adding all of them together, is that possible to be 1? No, like it's infinitely many. Doesn't matter how small the value is. Like when I keep adding them forever, it definitely will go beyond 1. So you can't have probability on a single point. So you must talk about in between a range. What's the probability in between a range? Okay, any questions here? No. Okay, still quite easy here. Number 3 is something you need to pay attention. Number 3, we talked about that already. So the total area and the curve must be equals to 1. So which means the density function area must be 1 because it's represent the total probability. We finished talking about that. The next line is important. To enable the area of the curve to be 1, we normally use hybrid function to represent density function. Okay, why hybrid function? Just say for any graph, like for example, e to the power of x, the area might not be 1, right? If you think about negative infinity to positive infinity, like it just keep increasing forever and the area can't be 1. So I must restrict my domain to use part of the function only and I have area of exactly 1. Like for example, from 0 to 4, like for a curve. Like for this one, if I keep continuing this way, it's not going to be exactly 1. Or say, for a quadratic, I can have negative as well. Like if you go downwards, I will have negative area. I can't use all the function, all the x values. I can only use part of it. Okay, so for this one, I use -1 and 6. What's the probability on the left-hand side of -1 on the right-hand side of 6? What do you think the probability will be? What's the probability that x equals to 7, for example? 0. Like I can't have probability more than 6. I can't have probability less than -1. Same as the water bottle question. Like I can't have water below 0. I can't have water above 600 mils. So they are not possible to achieve. So I will have probability 0 at those values. Important thing in exam, okay, I will see who get this wrong. I will be really mad. Okay, I teach that at right beginning, and it's something exam always test is sketching the density function. You know, like you have -1 to 6, you sketch this curve already. But how about the rest of the point? Your x value can be negative infinity to positive infinity. So what's the other point? You must show fx equals to 0 for the rest of that. I need to see those 2 black lines there. Okay, so you need to indicate for those values I have density 0. I don't have density, I don't sketch it. I don't have probability, but I need to sketch it. So your graph is actually, for example, this one is a cubic function. Let's say that's a gx. So your density function should be fx equals to like a gx when x belongs to -1 to 6. That's how you represent it, and it is equals to 0 otherwise. Okay, except those points, I will have 0 otherwise. So for the rest of the place, I have density 0. Okay, I have density 0. Only from -1 to 6, I have density, which follow the function gx. But for the rest of the place, for the rest of the x, I will have 0 otherwise. You must sketch those 2 horizontal lines on the axis, like those 2 black lines. I don't care how you do it, like you must sketch it. You must make me view, like I can see there are 2 horizontal lines for the other values. So this is always something testing, and doesn't matter how many times I just talk about that, you always get that wrong. Okay, just always, every year happened, like I will see who get this wrong this year. So make sure you sketch those 2 horizontal lines. I've scared you at the beginning, so make sure you remember for the rest of the year. You just need to remember for 4 more months and you can forget about it. Okay, so 2 black lines there. Okay. Let's have a look at example 1. Consider the function, this one. What function is that? Quadratic. Okay, quadratic is only available from 0 to 2. Okay, only available from 0 to 2. This function only useful for 0 to 2. So 0 elsewhere or otherwise, so it's 0. Okay, first question asks you to show fx is a probability density function for a random variable x. Obviously, your x can only take from 0 to 2. That's the possible value for x. There are 2 steps to show this is a density function. First, I need to sketch the graph and then really see this graph is all above the x-axis. Second, I need to antidiff the fx from 0 to 2 to show the area is actually 1. Okay, so there are the 2 things we need to do. So let's sketch it first. Well, you can sketch your own graph and I'll sketch mine. if it's a show that question, okay, again, I mark the set like this for this time, and just show that questions. You don't write enough step. Like a lot of you don't write enough step. Like again, show that question is use your own way to show the answer, not using the answer in the question. You need to show all the steps as detailed as possible. Sometimes at least 3 lines needs to be given for normally one question. At least 3 lines needs to be given. Okay. Your graph needs to be looks like exactly the same as my one. You need to label the 3 point, turning point, x-intercept, and horizontal the y equals to 0 for the rest of the values greater than 2 and less than 0. You need to sketch that line. Yes?
Doesn't matter if you draw arrows on the line.
That's fine. That's fine. I just don't like arrows. I feel like it's too messy, but like if you like to sketch it, that's fine. Just make sure your arrow is not touching with any asymptotes. Like if you have asymptotes, it's not touching any part of your asymptotes. That will be fine. Okay, I have shown the first step. So after you sketch this graph, this is the y equals to fx graph. Y equals to fx graph. So you will say first, fx is greater or equals to 0 for all x. Okay, that's the first statement you should make, because the left-hand side graph, I should have that greater or equals to 0. Also, how I find the turning point. Because the x-intercept is 0 and 2, so the middle must be 1. Then I sub the 1 back into the question. I have negative 3 over 4 times 1 times negative 1. I have 3 over 4. So that's how I find the turning point. Second, I need to show, okay, a lot of students doing this. And then say finished. It's not finished. Okay, this is not show that question. You can't even write the equals to 1 here. Like you don't know that equals to 1. Do you know what is it? Without calculation, you just assume that should be 1 because it's a decimal function. But now it's asking you to show it is a decimal function. So you need to show that equals to 1. So you can't even write equals to 1 there. Just really be careful with how you prove things. Like you don't assume anything at the beginning. You do your calculation. So 0 to 2 minus 3 over 4 x squared plus 3 over 2 x dx plus minus a quarter x cubed squared Okay, so the area, you have shown the area under the curve is 1. So all of this needs to be done by hand because it's to show that. Well, I believe everyone can antidiff the quadratic and sub the values in and then find that equals to 1 in the end. Okay, next one. Find correct two decimal places. X less than 1.5. So less than 1.5. A common mistake is students put the integral value from negative infinity to 1.5. But be aware of what x can take. So this question, the lowest bound is 0. So you enter it from 0. So take from 0 to 1.5. So less than 1.5 is start from 0. And then you put the function in. That's minus 3 over 4 x squared plus 3 over 2x dx. We'll expand the formula here. And that's minus a quarter x cubed plus 3 over 4 x squared. Put 0, 3 over 2. You have 27 over 32. I hope I get that right. Yeah. Someone use calculator? Okay, good. Well, the rest of that, I'm not going to show you every single question. Well, the rest of them is just basically integral from 0.3 to 1.8 of the fx function of the x. And you can calculate that by hand approach or using calculators. Most of the question will be done by using calculator. For this one, what's the formula can be expanded to? Well, it's a fraction, so what's the top, what's the bottom? Yeah, so what's the intersection? To 1.5, that's right. And the bottom? Less than or equals to. Okay. You will get used to it. We do a lot this chapter. And then you can find the integral of 0.75 to 1.5. Okay, so that's what we'll have. And you can use calculator to do that. Well, this lesson is basically calculations. So this is the first one. You know, like I said, for every distribution, we talk about 6 things, talk about probability, mode, median, mean, variance, standard deviation. This lesson is basically talk about how do you calculate probabilities. Alright, next one. Find correct to 2 decimal places the value of A such that probability x greater or equals to A gives you a quarter. Well, greater or equals to A, so it's A to 2. Okay, so it's from A to 2 of the function. And that gives you a quarter. How we can do that? Good, Cass. Cass, well, I'm not going to do this by hand. When you solve for this, you know, you put, I shouldn't write it here, okay? So you do menu 3-1, so it's the solve, and you put that in, and you solve comma A. What I will do is I will restrict the domain for A, or if you can restrict, you can see it by yourself. So I it will restrict it to 0 to 2 because A can only be valued from 0 to 2. For the rest of the place, it will be less than, it will be 0. So the probability will be 0. So it will be in between 0 to 2 and then see which one, what value you get. Just exactly type in whatever we have here and you can solve out values. Okay, this one, like, I want you to do this one by hand and this one by CAS. Okay, this one by hand and that one by CAS. And you can get example 3 done as well. Well, you can do this one by CAS, 3 by CAS, and example 4 by hand. Okay, there are 4 more questions. I want you to do those 4 questions and I will get your sack here. When you finish, you can come to exchange your sack. Okay? It's not going to take long, 5 minutes.